In this module, we will delve into the concept of functions, which are essential tools for automating tasks, reusing code, and addressing complex problems efficiently within the R programming environment. Learning objectives. 1. Grasp the foundational principles of functions and their syntax to establish a solid understanding. 2. Explore the use of parameters to enhance the flexibility and utility of functions. 3. Examine variable scope, distinguishing between global and local variables to facilitate effective coding practices. 4. Apply the knowledge of functions to solve practical health data challenges, thereby reinforcing learning through real-world application. Significance. Mastering functions is crucial for streamlining workflows, enhancing reproducibility, and improving efficiency in health data analysis. By the conclusion of this module, participants will be equipped with the ability to construct and optimize functions in R, enabling them to tackle real-world analytical challenges effectively. Let us proceed with our exploration. Definition. A function is a reusable and self-contained block of code, specifically designed to perform a distinct task, which can be executed multiple times throughout a program. Purpose of functions. Functions contribute to programming excellence in the following ways. 1. Code reusability. Functions significantly reduce redundancy by allowing developers to reuse code components rather than rewriting the same logic multiple times. 2. Parameter. Specification. Functions can accept inputs or parameters, which enhances their versatility and allows for the customization of their operations based on provided data. 3. Improved readability. By encapsulating tasks, functions enhance the readability and maintainability of the code, making it easier to understand and manage. Example. In R programming, the built-in sum function efficiently calculates the total of given numerical inputs, showcasing how functions can simplify complex operations with minimal code. Takeaway. Functions are fundamental to programming as they promote better organization, increased efficiency, and greater adaptability in code management and data workflows. In this segment, we will explore the fundamentals of defining a function in R, adhering to a structured approach that enhances reusability and clarity in your code. 1. Function. Name. This is the identifier you assign to your function, enabling you to invoke it conveniently in your code. 2. Function parameters. This portion is critical as it defines the inputs or arguments that the function will accept. Tailoring these parameters allows your function to cater to various data inputs and scenarios. 3. Code block. This section encompasses the core logic and operations that your function will perform, transforming the inputs into meaningful outputs. 4. Return statement. Finally, the return statement explicitly specifies what the function will output after execution, allowing for seamless integration into broader analyses and workflows. Now, let's proceed to illustrate these concepts with a practical example. We explore the fundamental concepts of creating functions in R programming. To start, let's define a function using the following syntax. Hello, function, print, hello. In this example, we define a function named hello. This function, once invoked, will output the text hello to the console. To execute the function, we simply call it by its name, as demonstrated below, hello. By executing this command, the function will be triggered, resulting in the output of the string hello displayed in the R console. Upon running the function, the expected output will be hello. Let us explore the importance of using parameters in functions to enhance their versatility and efficiency. A parameterized function is designed to accept input values, allowing it to adapt its behavior based on the provided arguments. Consider the following example. hello, function name, print, paste, hello, name. When we call the function using hello, Sammy, the output produced will be hello, Sammy. The key takeaway here is that functions equipped with parameters offer a higher degree of flexibility and reusability, enabling them to accommodate a variety of inputs effectively. Let's explore how default parameters can enhance the flexibility and usability of your functions. Let's begin by defining a function with default parameter values. In R, you can specify defaults within the function definition as follows. Function param south default value. For example, consider the following function. Hello, function, name, Frank. Print, paste, hello, name. By calling hello without any arguments, the output will be hello, Frank. If we provide an argument such as hello, Sammy, the function will override the default, resulting in the output hello, Sammy. Utilizing default parameters in your R functions not only makes them more versatile, but also enhances user friendliness. This approach ensures that functions can operate seamlessly, even when no input is provided. Let's dive into how we can create a function that adds two numbers together. First, we define our function using the following syntax. Add numbers. Function num1, num2. Return num1 plus num2. In this function, add numbers, we take two parameters, num1 and num2, and utilize the return statement to send back their sum. Next, we need to call this function to perform the actual addition. We can do this by passing two numeric values as arguments. Result, add numbers 4, 5. Here, we are calling add numbers with the values 4 and 5. The result will be stored in the variable result. To view the output of our operation, we can simply print the result. Print result. Now, outputs 9. Let us explore the concept of variable scope, its types, and its importance in code efficiency. What is variable scope? The context in which a variable is defined and can be accessed. Understanding scope is crucial for managing variables effectively and avoiding conflicts in your code. Types of variable scope. Global scope. Variables that are accessible from anywhere in the program, both inside and outside functions. Example, a variable declared globally can be modified or referenced by any part of the code. Function scope, variables defined within a function that can only be accessed by that function. Variables created within the function remain inaccessible outside of its context. Local variables, temporary variables that exist only during the execution of a function. Once the function execution is complete, these variables are destroyed and are no longer accessible. Understanding variable scope is essential for writing efficient and error-free code. Let's review the key concepts related to functions, which are fundamental elements in programming. Functions. Functions enable the encapsulation of code, promoting reusability, and enhancing organizational structure within your programs. They play a critical role in simplifying workflows by automating repetitive tasks, thus ensuring consistency in execution. Parameters. The introduction of parameters is essential as they allow functions to accept varied inputs, thereby increasing their flexibility. This adaptability enables functions to handle diverse scenarios without necessitating alterations to the core function code. Scope. Scope pertains to the accessibility of variables in your program. We will differentiate between global and local variables, underscoring how variable scope influences the functionality and management of your code. We encourage you to practice these essential concepts through the Codio exercises found in Session 2 of Module 2. In the upcoming session, we will explore lists, further broadening our understanding of data structures in R. Thank you for your attention.